Let's finish up lesson 1 and finish talking about Earth's geosphere. We're going to talk about the actual structure of the Earth, the solid part of the Earth. And I'm sure that you are somewhat familiar with the main structure, but let's go over it maybe in a little bit more detail. I'll start with the outermost part of the geosphere, that is the crust. See here, that's what we live on, that's what we know, and the crust is under the layer of soil on the continents and under the ocean, and it's really made of two different kinds of crust. You have the continental crust, which is a lot more or a lot less dense, and it's a lot more thick, and it's made of all three types of rock. It's made of the igneous and the sedimentary and the metamorphic rocks, whereas your ocean crust, if you see here, is a lot more dense and a lot more thin, and it's mainly just igneous. Now you'll have some sedimentary deposit here along the edge of the coast, but all of this is just that volcanic igneous rock here. And if you see, it varies greatly in its thickness. The continental crust you've got can go down to about 43 miles, give or take. Under the ocean, it's about 3 miles. Now, if you look here, you've got the ocean crust has some different thicknesses, and the shows you kind of the different types of crust that we're looking at. In the Atlantic, however, there is a region where the crust is kind of gone, and you're actually looking down at the mantle, but we'll look at that here in a second. But notice the different types and the different thicknesses that we have here, and definitely remember that you're mainly just the two types, the continental, which is thicker but less dense, and then the thinner, more dense oceanic crust. Now, most of the crust is actually made of oxygen, and the reason is it has all of these other elements, silicon especially, but they're oxides, so they're these metals mixed with oxygen, so it would be like silicon oxide, which is like a silicate. So most of our crust is made of these, but has such a high percentage of oxygen because it's mixed in with all of these other elements. Now let's look at the mantle. The mantle is actually about 67% of Earth's mass. So you can see here kind of the relative size there. It's the biggest chunk of our planet, and we don't really get an opportunity to study it because we haven't broken through on the continent, and where it is exposed in the ocean, it's hard to get down there, and it's hard to get any kind of samples. But let's look at, there's different layers to the mantle. So we kind of just think of it as, oh, it's just this big thick part, but it's actually a lot more dynamic than that. So if you look here, see you have the different types of crust, but right below that we have the upper mantle, and the upper mantle is broken into a couple different spots here. You have the lithosphere, litho meaning stone. So this is the uppermost part of it, and the crust as well is known as the lithosphere. And that's a little more rigid, a lot more rock, heavier rock involved. But below that we have what's called the asthenosphere, and this is a little more plastic, meaning that it's a little more fluid. It's not necessarily a liquid, but it is not a very rigid solid, and this allows for the movement of the tectonic plates, which we'll get into later on. But this asthenosphere is a very important part of the mantle. Um, if you look here, you can kind of see a little bit more of a picture of what's happening here. You have, as the lithosphere kind of merges down under the continental crust, and you have different terms that you don't really need to know that much about, but you can see here what makes that possible. This subduction, what makes it possible, is this more fluid, very hot asthenosphere. Now, the mantle is really, it has three different zones. You have that upper mantle that involves both the lithosphere and asthenosphere, and those are kind of right at the top of the upper mantle. You have the transition zone, which runs down to about 410 miles below the surface, and then down to almost 1,800 miles below the surface, you have the lower mantle. Now, each of these is composed of different types of minerals, types of rock, olivine, and then these are just kind of different morphologies or versions of olivine. Olivine is like a magnesium iron silicate, and so as it gets down further, you have heat and pressure working on it, and it changes into this wadsleyite, ringwoodite, and then further down where it's under even more pressure, perovskite. And then as we move further down, we get to a very interesting part. We get to the outer core. And the outer core, from about 1,800 miles below the surface down to about 2,100 miles, but it's a liquid outer core. So you have this, within this pretty solid mantle, you have this area of molten iron and nickel. And you can see here that the outer core sits down here. Within the center of the outer core sits the inner core, which is solid. So you have this kind of fluid bubble, and in the center of it is our outer core, liquid outer core. And so within that liquid outer core, as the inner core spins, rotates in it, it actually creates this magnetic field, which we'll get to here in a moment. So here's our solid inner core, which has a radius of about 760 miles. So from the surface of this outer core, you have down to the very center, 760 miles. And so now what scientists are thinking is that they're breaking this inner core into more layers, and they're saying that it has this inner core here, and then an outer inner core, and then kind of this shell that goes around it. But it actually spins on the Earth's axis as well, and this creates, as I mentioned, the magnetosphere, the Earth's magnetic field. It will create gravity, so you have heat spinning, heat as it spins, and so it rotates faster within this molten outer core, and that is what creates the magnetic field. And this is where it's very dense. It is iron, solid iron with some nickel in it. So same kind of configuration, but a lot more dense. And this is what is creating gravity, what is creating magnetic field, and pulling all of this other material, all of the mantle and our crust and our atmosphere and hydrosphere, and keeping everything down, has to do with the relationship between this solid inner core and this liquid outer core.